We're honored to welcome Mr. Nachiketa Hebar as a speaker for our second guest lecture as part of the Winter School for AI and Robotics. Welcome, sir.
Hi, thanks for the introduction.
Yeah.
Mr. Nachiketa Heber is presently a computer vision engineer in Aviros as well as a YouTuber. He has received his Bachelor of Technology degree from the Vellore Institute of Technology in ECE with specialization in IoT and sensors. Besides working as a research intern in IIT Nagpur, he has also worked in a variety of applied research projects, and his research expertise is in the field of application of computer vision, use of IoT, and machine learning.
So today he'll be sharing with us some insights on making a career in artificial intelligence as a fresher, like what we can do as freshers to get interested in this field. So please, sir, I'll be handing over the stage to you right now.
All right. So thanks again for the introduction, both of you, and really excited for this session because I was in the similar position as all of you just a couple of years back when I was trying to get into the marketplace. So let me just tell you what we'll be doing for this session. But again, I would just like to confirm with the host, like, how much time do we have? We have till 6:45. Am I correct on that?
Yeah, 6:45, 7-ish, as much time as you need, and plus some time for questions at the end.
All right, cool. So let me just first of all share my screen. Let me know if it's visible.
Yeah, it's visible.
All right. So we'll be talking about what, as college graduates, you can do to make a career in AI, because job opportunities is slightly complex to navigate in this field, because there are software engineering roles which you're normally typically preparing for. AI is in a lot of hype these days. So you don't really know what to target. AI has a lot of subsets inside it. You can be a machine learning engineer, you can be a deep learning engineer. There are a lot of variations which I'll be talking about. And I'll tell you exactly how to navigate, how to prepare yourself over the course of the next 1 or 2 years. I'm assuming a lot of you are in your second, third year, or even first year for that matter. So you'll have some time to prepare by the time the placement seasons arrive. So before that, let me just reintroduce myself. I am a computer vision engineer at a startup called as Aviros. So I'll be talking about what the company does, what I do over there, because that will allow you to consider another career choice as well, right? Because again, my most common doubt when I was in my second year was that I didn't know what an AI engineer would actually do. What do I have to do in my job day to day? So that is something that I'll address very briefly. And I'm also an AI YouTuber. You can check out my channel as well. I talk regularly about different types of algorithms inside machine learning, AI, and again, how you can use those skills to get a job. And these are my social media handles on LinkedIn, GitHub, and YouTube. Feel free to connect with me on that after the session as well. So to start with, again, I said I'm a computer vision engineer. So that falls under the bracket of AI engineer, and I'll tell you how. So first of all, a little bit about the company that I work at and what I'm exactly doing. So Aviros is the world's first video AI operating system. And that's slightly confusing, but all of you are Android or iPhone users, you know about Android and iOS, which are operating systems for mobile phone applications. We do the exact same thing, but specifically for video AI applications. So like you have a Play Store, we have something called as the App Stack, which is basically a collection of all video AI applications. So whatever, if you have for applications like Temple Run or let's say Facebook, you have all video AI related applications. When I say video AI, that means that's an application which takes some video and add some intelligence onto it. It can be used to, let's say, recognize a person's face. It can be, let's say, used to detect if a person is wearing a face mask or not. And there are endless applications that are coming these days. So as an AI engineer, what I am supposed to do is, first of all, build these computer vision applications which are able to analyze these videos smartly and take some action based on that. And at the same time, ensure that they are scalable and can be delivered to a client and work end to end. So as OS, one thing is again providing a marketplace where you can download and install applications. The second thing that an OS does, it allows developers like us, like if you are familiar with a little bit of app development, you know Android provides you Android Studio, right, which allows you to develop AI applications. Similarly, Aviros is an operating system which allows developers like us. So if I'm a computer vision developer, I simply have to bring an AI model, and there are countless of integrations that you need to do to make sure that it can scale up to, let's say, 10,000 cameras. So all of that integration is taken care by that operating system, and we only have to focus on the AI algorithm. So this field of basically taking videos and deriving intelligence from it comes under computer vision, which is a subset of AI. So this is also that you could that could be something that you could be doing if you want to become an AI engineer. So that was just to give you an idea of one possible career option which I am currently pursuing. But I'll talk about other things that you can do and how you can easily do that as well. So I have basically created a roadmap, but again, let me tell you about the different kinds of jobs that you can target, right? Because AI is again very vast. There are different types of titles. All of them are mostly overlapping in some sense. So after your final year, after you graduate, you could become a data scientist at a company, right? You could be a machine learning engineer. Now again, these terms are confusing, but just understand that if you're a data scientist, all you're doing is you're studying data, you're analyzing it, and deriving some sorts of insights. You're doing some sort of predictions that allow to convert that data into actionable insights, right? A machine learning engineer would also be doing the same thing. The only difference is how you are using data smartly. For example, if a machine learning engineer would typically use machine learning to understand data, right? So for example, let's say you're a Netflix user, you get recommendations all the time that if you watch, let's say, Mirzapur, then most probably you like Gans or Wassapur too. So recommending this based on your interest is basically understanding your data, right? So that is something a machine learning system would do. Now, a subset of deep learning is a subset of machine learning is deep learning, which uses a component called as neural networks. So you could also consider being a deep learning engineer. Now, again, if you're a deep learning engineer, you can be a lot of things. If you're like me, you're interested in using videos smartly, getting intelligence from video or images, then a computer vision engineer could be a possible job for you. But if you're more interested in audio or text and understanding and making sense of that, right? Let's say you want to do Twitter sentiment analysis based on the kind of tweets that people are making. You want to understand how the feelings of people are changing relating to a particular product. Then natural language processing could be the field for you. Again, a lot of things. There could be an ML ops engineer. So whatever a machine learning engineer does, he builds ML models, right? You need to make sure that they're integrated with the system. They are scalable. You need to make sure that the complete life cycle from training a machine learning model, integrating it into a product, and retraining models. That is something an ML ops engineer would do. But to be honest, in today's day, even a data scientist, even a machine learning engineer needs to have knowledge about all of these components. And again, you might have seen titles like data analyst, business analyst on people's LinkedIn profile. So these are also some parts of them are overlapping with AI. But to be honest, it depends on what the company is and what they do. So a data analyst could be someone who uses Excel to filter data, right? So that is not, they are not indulging in AI, but that's also a data analyst. But a data analyst could also be someone who is using AI models or using programming languages to analyze data. So there are lots of variations when it comes to AI, and that is something you have to figure out based on where your interest is. Now, the number one challenge is that the jobs are limited. When you're targeting AI, initially, if you are believing into the hype, you would feel that there are tons of AI jobs out there. But the problem is a lot of AI engineer jobs are reserved normally for master's graduates, PhD graduates, or people with some experience. As a fresher, it's slightly more challenging to get these jobs. And that is exactly the point of this presentation, where I'm going to walk you through a roadmap. So I've prepared a roadmap that you can follow from the stage of a beginner to the point where you'll have good enough skills to apply to a company. I'll also be telling you about a platform which you can use to apply for jobs and what kind of jobs you need to keep in mind. There's some myths that I'm also going to burst, which people initially have when navigating the AI job scenario. So we're going to be talking about all of that. And if time permits, what I'm also going to do, I'm going to teach one particular machine learning algorithm because I want you to know how to approach an algorithm, how to study that. If you know how to study one algorithm, you can study 1,000 algorithms as well. So let's see based on how time permits, but at least we'll cover how to navigate AI jobs and master that process. All right. So let's say you're starting from over here where you're a beginner, right? You don't know anything about machine learning, or let's say you just know what machine learning is and you want to start uh, building an expertise on that. So when it comes to machine learning, deep learning, AI, it's filled with learning algorithms, and you have to learn that. The first step, which I recommend, is master one algorithm. Right? Notice I have not said learn one algorithm. I have said master that because the competition for AI jobs is intense. All right, and it's over a wide span of age. So you are young graduates right now who are trying to get into the AI field, right? There are people who are 25, 26 years old who are software engineers who are trying to switch to AI. And there are 30 years old as well who are trying to get into AI or are already into AI. So you're competing with over a wide span of age. So what you need to ensure is that even if you have a very limited knowledge, make sure that you're good at what you know. So even when you're applying for AI engineer roles as a fresher, companies will not expect you to know a lot. But whatever you know, it's important that you have an expertise on that. So when I say master one algorithm, there are three components inside an algorithm that you need to be good at. One is the intuition. So the intuition basically means what that algorithm is trying to do. The second component is the mathematics. So machine learning is just glorified statistics and mathematics that is used to learn from algorithms, right? It's all comes down to if you're good at mathematics or not. So you need to understand mathematics. Algorithms would have certain equations that they're using to map an input to an output. You need to be familiar with the equation, with the variables, how exactly that's being derived, right? So initially you need to understand all of that. Finally, when you understand when you've understood what an algorithm is trying to do and you understood the mathematics behind that, then you use some sort of programming language to implement what you know. So it's very important you have a strong hold in all of these three components whenever you learn an algorithm. So to take one example, I'm going to start with one algorithm. Again, if time permits, I'll dive deep into the mathematics of that as well. But let's just take linear regression, for example. I don't know if you're aware of this or not, but whenever you take a machine learning course, let it be on Udemy, let it be on YouTube, the first algorithm that will teach you is linear regression. So when I'm talking about the intuition, you need to understand why is it called linear regression? Like why is it called linear? Why is it called regression? What significance does it hold? You cannot afford to be vague when it comes to any concept in this, right? So I'll also show you how you can do it actually, but you need to understand the name first of all, right? So if you know linear regression, it's just an algorithm which tries to find a best fit line on the data, right? So let's say you want to predict, you're given a list of housing prices. Let's say you have 10 houses, you know what is the size in square feet of that house, and based on that, you have information about what is the price of the house in, let's say, dollars. And you want to find a line that best fits this data. So in the future, whenever you have a, let's say, a new point, you're given the size of the house, you're able to successfully predict the price as well. So this, what the algorithm is trying to do is the intuition part. Second, how does it find the line? What equations is it calculating? How is it optimizing the line? That is something you need to understand as well. Finally, once you've done the intuition, once you've done the mathematics, then you move on to the coding part, where you understand the different Python libraries or different uh, uh, packages that you can use to implement that model. That is something which you have to practice and implement for a particular project. So whenever you're starting with an algorithm, this is the first thing that you need to understand. Also, just to add on over here, if you have any doubts at any point, leave that in the comments or add that in the chat. I am actually not able to be the chat because I'm not a team member. So maybe you could raise your hand or you could leave it in the chat and someone from the organizing team uh, would let me know what the doubt is well. So should we leave that for later or should we allow people to ask questions in between? I think that would be better because that will allow people to learn with the flow as well.
Yes, according to your convenience, we can do it.
So I think Shubhra has raised.
I have a question that what language we can use except Python? Does C++ help us in machine learning?
Can you please repeat your question?
I mean, except Python, which language should be helpful for us for AI?
Oh, so are you asking which programming language should we use for AI?
Yes, yes, I meant that.
Yeah, so uh, in the industry, right, the primarily two languages right now which are most popular, which are Python and R. But most companies uh, use Python right now. Python is used for building those AI models. That is the number one reason is that a lot of companies are using it. It has a lot of support, so it's very easy to implement things when you're stuck in doubt. You have a huge developer community help you, and but to get things in production, right? Most companies will use C++. So in my company, we work on Python to build AI models. Then we use C++ to integrate that into a product because C++ is faster than Python. So I would say Python and C++ would be a safe bet if you're targeting AI rules.
Thank you.
All right, great. So if anyone also has a doubt, they can raise their hand and we can answer that because otherwise it will be tough to recollect which doubts you had in which area. So the first step again, once you learn an algorithm, master that. The next step is to implement that on real world data. So let's say you did a linear regression, you understood a linear regression model, you know how to call various Python packages to implement that. Take some data set, preferably a big data set, because that's how real world data looks like. You won't be given a data set of 20, 30 points and asked to build a model on that. Most likely you'll be given a data of, let's say, 10,000 rows with 10 hundreds of columns with data which has missing rows, missing columns, some have text data. So practice on real world data. So where can you get that? There are lots of data set sites out there. You can go to kaggle.com and get a list of data sets related to any problem you want to work on. So get a data set, a real world data set, and practice on that. That will teach you a lot about feature engineering. Right? Again, if you're looking to work as an NLP engineer, you could work with text data. You learn how to convert that text data into numbers, what kind of challenges you face in that. If you're working with images, you learn a lot of data augmentation. You learn a lot of image processing that is required to feed images into a neural network. So practicing on real world data is really important, and that will get you an idea of how things work in the real world. So after every algorithm you learn, implement that on real world. Learn one algorithm, learn the intuition, learn the mathematics, implement that in programming, then go to implementing the same on some real world data. Right? That is where you have a very strong hold on one algorithm. Right? So right now we're just on linear regression. Let's assume we're doing everything just using this one algorithm. So once you have done that, right, the next step the next step is to build an end-to-end product using what you've learned, right? So if you have built a machine learning model, most companies which are serving products to customers, their customers won't be interacting with the model. There will be some sort of interface. It could be a web app, it could be an Android app, where the user would be interacting with the machine learning model in the backend. So it's important you know how to integrate the machine learning model that you have built into a product, right? You could create a web app, right? You could create an Android app. You could create an API using Flask, or you could deploy your model into the cloud. You can host on AWS. You can host on Heroku. But you need to be aware about the end-to-end life cycle, right? From the part of obtaining a data set, cleaning it, pre-processing it, building models on it, post-processing the data, and finally getting it to the point of an end-to-end product. So for every single algorithm that you learn, I would recommend that you do this. So these three things that you are doing will ensure a good technical expertise. Once you're done with this, the next step, which I want you to go to, is document the project. So whenever you complete one project, do not forget about it. Do not let it rust. Document it somewhere. It could be either on GitHub, it could be through blogs that you write, it could be videos that you're creating on that. Or the best thing that you can do is write some research paper about it. But research papers are slightly more challenging. They require that the project that you have done have some sort of innovation in it. But that is something you can do. Or very easily you can post about your project on LinkedIn as well, where you might end up grabbing the attention of recruiters on LinkedIn who are working in a similar domain related to the project that you just did. So right now with the competition, this is very important that you're documenting and maintaining some form of social presence, right? It could be through a strong GitHub profile, it could be through a Kaggle rank, right, where you are participating in machine learning competition, or again, blogs, videos, papers. So the best thing about this, so my YouTube channel acted as a video resume for me for a lot of companies. And whenever I was to attend an interview, right, let's say I forgot some concept like the derivation of support vector machine algorithm, all I would do is I would go back to my own videos, watch that at let's say 1.5x speed and revise that. So whenever you have written a blog and you have documented your journey before an interview, you simply go through what you have documented. And that is the best form of revision. Because whenever you've done something on your own, you recollect that very easily, right? So documenting is again a very important process. So once you have done this, next thing is repeat with the other algorithms. You've done linear regression, do this entire process, go on to the next algorithm. Let's say logistic regression. You've done that, go to the next algorithm. Go to support vector machines. Once you cover algorithms in machine learning, go to deep learning. But slowly and steadily, this will ensure that you are becoming a master at each algorithm that you're encountering. And that is the only thing which is going to keep you ahead of the competition. So this is the process that I want you to follow for learning AI algorithms. And now I'll tell you how to use that knowledge and actually have a chance at getting jobs. So again, before that, if anyone has any doubts, you can raise your hand and ask that, or we proceed to the next part.
Sir?
Yeah.
Yeah, Shubhra is repeating his question. Like, if you could recommend some programming language to start
So,
learning.
so I would recommend Python, and I would also recommend C++. So Python and C++ together, I would say it's a very good. But if you're just starting, I would say start with Python for once, because most machine learning models, deep learning models are very easily executable using the Python programming language, and it has a good support. Whenever you're stuck in doubt, it has a very big developer community which will help you build models easily. So yeah, I would say Python is good place to start with. And if you know C++, it's a good add-on because a lot of companies do that. Again, as I said, because it allows a faster execution of models. So start with Python and if possible, learn C++ also. But Python is definitely the number one choice that I would recommend to start with.
Okay, sir. Thank you. Shubhra,
Are
I
there
hope that answered your question.
okay? So are there any other doubts in the chat section, because that is something I'm not able to see.
Yeah, we've got another doubt from Yash. He's asking, how is the documentation of our work helpful to us? If you
Okay.
could please repeat that.
Okay. So basically, so I showed you my YouTube. Let me go to my YouTube channel, right? Oh, that's best form of showing. So right now, most of the projects that I've done, I've uploaded that on YouTube. I've basically taught the same thing, right? So whenever I'm applying to a company, I'm sending them my YouTube link along with that as well. So if you are a good writer, right, you could write on Medium blogs, and that basically allows you to stand apart from the competition to show you that you really know that. So let's say you learn linear regression, write an article about it in a way that even someone with no knowledge of linear regression can understand that. Second thing, today, because of the competition, having a social presence is helpful. So if you have a good GitHub profile, every interviewer or recruiter would definitely today look at a GitHub profile, would look at a Kaggle profile and see what you've done. So documenting your project will allow you to have a better understanding of AI algorithms, because when you write something, document something, your concepts get better. Second, it improves your social presence, right? So if you're a blogger, people will follow you. If you are making videos, again, people will see that you know something. Or if even you have a GitHub profile, people will fork your repository and use it. So it builds a social presence, which allows an indication that you are good at this. And lastly, again, it helps you stand apart from the competition when you're applying again. So in your resume, you can link your GitHub, you can link uh, your blog channel, or you can write about the research papers that you've published. So documentation is going to help in all these three things. So are there any other doubts?
No, for the timing, there are no doubts.
All right. So let's move on to the next part, is how to apply for jobs. So two things over here. First, have realistic goals. So again, when you're looking for AI jobs, you talk normally when you're looking for jobs in general, you target the top companies. But top companies like Google and Facebook, which you would normally target, are mostly off limits for the role of AI engineer or a machine learning engineer. You have a chance at these top companies if you want to become, let's say, a software engineer, because for the role of AI and machine learning, these companies, top companies, have very high thresholds of filtering. They would normally straight away write in job descriptions that master's or PhD degree holders or people with 5, 6+ years of experience. Because the reason for that is it's typically a hard field that companies won't expect by the final year of your engineering that you have that good amount of knowledge and experience that you'll be able to contribute to their product. So your best shot, which I would say if you are very keen on working in AI, is to apply for startups, because startups are more flexible and they are willing to give a chance to freshers if you are skilled enough, right? So I'll tell you how to apply. So there is a website called as angel.co. So that is where I got my job from, and that is typically a website specifically for startups. So this is the homepage for that. So I highly recommend this website for anyone who is looking to get a job at startup, and specifically in AI and machine learning, because you apply just like Internsula, but it's much better because it also kinds of make sure that companies reply. They'll reject you or accept you, but they'll reply to your applications, right? So what you do is you search for a job title, you search for a location. You have lots of filters over here based on the skill set, the languages, the kind of industry you want to work in. Is it an internship, full time, and the kind of required experience for that job? And again, the company size, the funding stage, and a lot of things which you need to know about a startup. So you can see a job coming up over here for machine learning engineer, and you can basically check about the company, what they're doing, and if that seems like something that you're interested in, you can apply. So again, if I'm talking about my particular company, we are also listed on angel.co. This is where I got my job from. So again, you will be able to see the jobs for any company that you want to work at, different kinds of roles, what their experience is, and it's very easy to apply basically. So I'll also tell you when you want to apply, right, you have to basically leave a message, uh, basically to the founder or someone at the hiring side. I'll also be talking about the template that you should follow. So first of all, remember this website angel.co. It's very helpful if you want to get a job at a startup. The second thing is again LinkedIn. So in LinkedIn, again, uh, you can look for recruiters, you can reach out to company professionals for referrals. You can, if you're just active, a lot of people post job openings. I see a lot of startup founders posting all the time that they're looking for an ML engineer with 1+ year of experience, or there are companies who want to freelance that sort of work. So being active on LinkedIn is always a good idea, and being present, which means actively putting out your projects and documenting your learning, is going to attract attention of recruiters. You don't know who will like your post and who it will reach out to, and they might be interested in what you're doing and directly reach out. That happens a lot on LinkedIn. But given that you're documenting and maintaining a social presence, so these two are very easy, I would say, platforms that can help and make job process, application process very easy. So again, startups, Angel.co is filled with startups, and startups are generous. You will get to play a better impact over there, and they pay just as well as the top companies. So if you're keen on AI, I would say that is the best uh, place to target. Next, whenever you're applying, you need to message the companies, right? Even if you're on LinkedIn, you're directly reaching out to companies, you need to message them. So here is a uh, kind of template that I normally typically follow, which seems to work well. And in general, it makes sense as well. So what you need to do is you need to study. Whenever you're approaching a company, when you want to apply for a company, it's very good idea to study that product. So if you go to angel.co, you want to apply to a company, again, I'm taking the first company that pops up, understand what they do. Most companies will have a website link as well. Go to the website, go to their LinkedIn profile, check what kind of products they are building. That's the first thing. And see if that seems something that excites you as well. Right. Second thing again is to understand how you fit in their product and how your tech skills can help. So let's say the company you're targeting is a computer vision company, right? It works on video data. And let's say you have done some projects which were interesting on images, right? On videos that you did on Kaggle, right? You publish it on GitHub. Or if you're targeting a natural language processing company, then let's say you did some NLP projects. Or if it's, let's say, financial company, let's say you did some sort of work, data analysis, data prediction on some finance data. To understand how your tech skills and the projects that you've done fit into their product. You need to understand how you can complement them, first of all. Next is link or show proof of your expertise on that particular skill set, right? So that could be a GitHub link. That could be, again, as I said, when you document, you can write blogs, videos. Let's say you want a hackathon, talk about that. If you have a good LinkedIn presence, you can link your LinkedIn or your Kaggle work. You can leave a link to your Kaggle notebooks. Whatever you've done, link that, and that is basically a proof of expertise that, let's say, companies working in computer vision. I have also done computer vision projects. I have worked on images. Here is the proof of that, and repeat this for every company, right? You need to tell the company that this is how you can benefit them, and repeat this with an expectation of 10:1 reply, right? Which means if you're applying to 10 companies, accept, let's say, an interview call from only one out of them, or a reply from one out of them. Because again, a competitive landscape, and you need to be really persistent with this, right? So this is a process that you need to keep on iterating. So that is, I think, all that you need to understand about the job application process and how to approach an AI algorithm. So I think we have some time left. I'll also talk about what machine learning is, a little bit about how you need to understand that, because that is important. Because again, as I said, lots of algorithms, but if you know and study one algorithm in depth, that is fine. You just need to be able to iterate that. So again, any doubts at this point, I would love to address that.
Yeah, Akash Kaushik is asking if there are any resources.
Uh, any resources for Akash? Could you be a little bit specific? Any resources for learning? Any resources for job applications, jobs, or uh,
For learning about AI.
okay. So for AI, I would say you can write this down. Basically, there's uh, Stanford's course by Andrew Ng. So Andrew Ng is also considered as the father of modern machine learning. So his course is available on YouTube. You can just search Andrew Ng machine learning course. It's just free on YouTube. It's available on Coursera as well, which talks a little bit about statistics and machine learning algorithms. But other than that, I don't think a lot of resources are necessary that will just confuse you. So the process that I said, that is what you have to follow. So let's say you take any course, XYZ course from Udemy or again Andrew Ng's course. You learn one algorithm, you learn, let's say, linear regression. Next step is to again understand the intuition mathematics. Again, next step is to implement that in programming. So it's very likely that one course would not be great at both mathematics and programming. Let's say the Andrew Ng course is good at mathematics, but they don't talk about programming in Python. So simply search on YouTube linear regression in Python. That's it. Right? Linear regression on large scale data. So everything is available on the internet, but you just need to learn from that in a targeted manner. So as I said, you can start from Andrew Ng's course, but the mindset should be that I've learned linear regression. Let me look for everything about linear regression on the internet. So you can go to blogs. So obviously, if you search linear regression, the blogs are search engine optimized in that way that the blogs with the most viewership, which are the most helpful, would pop up on the top, right? Same goes for YouTube videos as well. So YouTube videos and blogs are enough for this. But the process should be clear in mind that learning an algorithm, learning the intuition, mathematics, implementing that, and repeat. So that is the only thing that I recommend when it comes to learning AI in general. So are there any other doubts, Tanushri, in the chat section?
No, not yet.
All right. So what I'm going to do is I talked about how we can learn machine learning and how we can learn algorithms. I'll also very briefly touch what machine learning is to give you a better sense and how we can go about learning algorithms in that. All right. So let's very briefly go about that. So the first thing that you need to understand about machine learning is where is machine learning used, right? You could be using Netflix, you could be using Flipkart, any sort of, you could be using Swiggy. All of the applications that you today interact with are using some form of recommendation system, right? You get personalized recommendations. All of that is machine learning. If you're going on Flipkart, you are getting recommendations that since you bought, let's say, sneakers, they might recommend stocks to you the next week, right? So machine learning is dominant everywhere where you're interacting with products today. So it's important to understand the definition. So if you go to Google, there's a very boring definition that you'll find, which is highly complicated to understand. I do not recommend you learn this. But of course, it says that it involves computers discovering how they can perform tasks without being explicitly programmed to do so. So this is, I feel, is something which is particularly designed to make it more confusing. But this is the technical definition. But to understand that, you can say that it's simply learning from data. That's one thing. And second is just glorified geometry. So again, when we talk about recommendation systems, right, it's learning from your data. It saw what did you like in the past week, what are other people liking that are, let's say, your age with your gender, and it's learning from that. And in order to learn from this data, it uses some form of geometry, it uses mathematics, and that's all there is to it. So that is what machine learning is in brief, right? So when we talk about we talked about AI engineer, machine learning engineer, deep learning engineer. Again, let's talk about the difference in that. So when we talk about AI is a very, very, very vast field, right? It's just a subset of a field of science which enables machines to mimic human behavior or makes machines smart, basically. So whenever let's say you say that I want to become an AI engineer, in reality, you'll be very likely, at least as a fresher, at least you'll be working on a very small subset of AI. Even in the industry, even with experienced people, people have an expertise on a subset of AI, right? So you need to understand all these subsets inside of it. The most popular one, again, is machine learning, right? So it's a subset of AI which uses statistical techniques to learn from data, and basically it will allow a machine to better perform with experience, right? If a recommendation system is bad initially, as it gets more and more data about different users, it gets better. So in order to do that, it's using some sort of statistics. So we'll talk about that as well. Now, deep learning is a subset of machine learning. It does the same exact thing as machine learning. The only difference is it depends on a component which is called as neural networks. So whenever you're using neural networks to learn from data, you can say that you're working on deep learning, right? So you could, when I say you're a deep learning engineer, you're working on this subset of ML. So when you start learning this, you can take some time to figure out where your interests are and then target jobs accordingly. So the first thing, right? Again, initially it's very overwhelming as a beginner to enter this field, but just understand how a machine learning model works, and that's a good start. Any machine learning model will primarily have two things that it uses. One is data. Again, I'm gonna stick to the Netflix example because that is something a lot of you will relate to. So it has a lot of data that this 18-year-old kid likes this kinds of movies, or this 24-year-old living in Mumbai, they like these kinds of movies. So it has tons and tons of data that is fed into it. The second component is a learning algorithm. Once you have that data, how do you learn from it? So all the entire game of machine learning is to be really good at handling all the data, different kinds of data that you can get at, and B, understanding the different kinds of learning algorithms and being good at that. Once you take these two, right, you can use that to do different kinds of tasks. You can do predictions, right? You can predict the temperature tomorrow. You can predict the stock price tomorrow. You can predict what movie this user is gonna like, what food is he gonna like on a Tuesday evening, or you can understand patterns in general, right? You can understand patterns of data. That is the two things that you would typically do using a machine learning model. So when I say master machine learning, you would primarily, at least one part would be mastering the learning algorithms inside of it. So you have three types of learning, and I'll just talk about what these three things are, a small Q&A about that, and then I think we can open up for more doubts in general. So three types of learning algorithms which are most prominently used. One is supervised learning, one is unsupervised learning, and the third is reinforcement learning. Let's talk about these three in a little bit of detail. The first thing is supervised learning, right? Again, any online course, any YouTube course that you buy will start with one subset of these three learning algorithms, right? Supervised, unsupervised, or reinforcement. Most typically, they'll start with supervised learning because it's primarily used a lot and easy to understand as well. As the name suggests, it is learning with supervision, right? So let's take the example of a project. Let's say you want to build an AI software or a machine learning model which can successfully differentiate between a cat or a dog. The goal is that you provided the image of a cat and it can tell you that, hey, this is a cat, this is a dog. So as I said, the first thing is you input the data to it. Second thing is you use a supervised learning algorithm that can learn from it. Now, when I say supervised, it means that it already knows the correct answers beforehand. It has the input and output beforehand, which means you will probably give it, let's say, 100 images, 50 images of a cat, 50 images of a dog. It will learn from it The goal is the next time you give it a cat, no matter how different it is from the original data set, it will be successfully able to predict that. So whenever you have the input and the output beforehand and you want to learn with it, right, you can monitor basically if the model is doing good or not. That is supervised learning. The second subset is unsupervised learning. Now let's say you have the same problem, but the only change is that let's say you do not know which one is a cat and which one is a dog. You just give it 100 images of cats and dogs. Cat being you don't tell it which one is a cat and which one is a dog. In this case, what a unsupervised learning algorithm would do is it can successfully differentiate. It can tell you that, hey, the species at the top is one different species and the species at the bottom is a completely different one. So this distinguishing is what it can do by understanding patterns in data. So whenever your data is not labeled, whenever you don't have the input and output beforehand, that is where you would go for an unsupervised learning algorithm. So just in this, does anyone have any doubts between supervised and unsupervised algorithms?
Yes, there are doubts present in the chat.
Or I'll love
So,
to address that.
Nidhi Nandwani is asking, what is data science and is it related to AI?
Okay, so data science is, as the name suggests, it's a science which allows you to study, understand data, take some actionable insights from it. Now, how you understand and analyze data depends on whether you can call it AI or not. In most companies, data scientist has overlapping things with an AI, right? You can do data science without AI. You can use Excel to smartly understand data, but you can also use AI to understand data as well, right? A data scientist could also be able to build a model that can predict if a user will like, let's say, a X movie or not. So the job of a data scientist is to understand, analyze, take actions from data. Yes, it is in today's industry, it is a subset of AI. It has overlapping things with AI, but in general, they have a lot of responsibilities as well, like ensuring that the models that you build can reach to thousands of users. So to answer shortly, yes, it's an overlapping, I would say, overlapping field with AI, and that is something people consider as well. Are there any other doubts, Tanushree?
Yeah, there is another doubt from Venkatesh. He's asking, what is the difference about solving a real world problem with machine learning versus solving it without machine learning? And when we
Okay,
use the phrase learn from data, what is the model actually doing?
that's a great question. So there are two questions, right? What is the difference between solving a problem with machine learning and without machine learning? And the second question was, what do you mean when you're learning from it, right? So primarily, right, what used to happen in traditional programming was you define the rules and based on that some action is taken. So let's say uh, you want to predict whether a user would like the movie Mirzapur or not. If you want to do that using traditional programming, there has to be a fixed set of rules that you can write based on which you predict. For example, let's say if I can give you a rule that if the guy is 18 years old, if that guy has seen a particular action movie, if that guy likes movies of violence, then yes, he will like Muzaffar. If I can write X, Y, Z conditions, a rule-based logic, then I can accomplish this task without using machine learning. So in traditional programming, what used to happen was you define a logic, based on that some action is taken. What machine learning has done is it allows a system to create this logic on its own. With machine learning, what you would typically do is you would just give it data of let's say 100 users and what they liked, what they disliked, and the model and the machine learning algorithms would automatically figure out what a user would tend to like, and based on that they can extrapolate that in the future as well, so that whenever a new user comes up that the system has not seen before, it can take a good guess so as to what they like or dislike. So machine learning will allow to learn from data to define its own logic, whereas without machine learning, you would have to define the logic on your own, which is very, I would say, unscalable in a lot of places. And the second thing, again, going back to my presentation, how do you learn from data? You use different kinds of algorithm to it. So uh, since we have a shortage of time, I won't be able to go into the details of a particular learning algorithm, but I'll give you a gist. So let's say you have this particular problem, right? You have something on the x-axis, you have something on the y-axis. You're trying to predict the price of a house based on the size. A linear regression algorithm would take all these points and try to find a line that best fits it. How it does that is something which is a whole other topic which will require another hour-long session. But it takes this data and uses statistics to basically understand that better and take future actions based on that. So that's how it learns from it. And I hope that answers your doubt.
Yeah, thank you, sir. For now, that's all the doubts we have.
Okay, so let's just wrap this up. So there were two algorithms, as I said. Supervised, when you know the input and output beforehand, right? That is when you would go for supervised learning. Let's say you have 50 images of cats, 50 images of dogs. You label those images, provide it to a model, it learns from it. Unsupervised is when you don't know the output beforehand. Let's say you give it all the 100 images, you don't tell the model that, hey, this one was a cat, this one was a dog. It simply understands the patterns in that, uses different kinds of clustering algorithms, and just learns to understand the data better. That is unsupervised learning algorithm. Last type of learning algorithm is reinforcement learning, which is primarily used in game playing software, where basically where you reward the algorithm to take desirable actions. So again, I won't go into the depth of this, but to give you a small intuition, let's say you're playing a game of chess and you want a machine to play that. So if you have a chess piece, there are certain states, certain positions in the chessboard where you would like to go to, right? So if the model takes those particular actions that, so the model is the agent in this case. It takes a particular action, let's say move the chess piece into a particular chess board position. You give it a reward. You give it a reward that if the position was desirable, and if it goes into a wrong position, you give it a negative reward, right? So based on these rewards and how it's changing the position, or also called as a state, the model tries to learn and gets good at this. So this is primarily used in game playing system, and this was what allowed a particular game called as AlphaGo. In the AlphaGo game, the machine learning models that were trained, they were able to beat the world champions of that particular game. So that was done through using reinforcement learning. So again, when you go about learning these algorithms, these are the three types of algorithms that you broadly encounter. So just I would like to wrap up with a small Q&A, basically give you different types of problem statement and get to know from you which learning algorithms, supervised, unsupervised, or reinforcement, would be a good choice for that. Like the first problem is, let's say there's an ad agency, right? They're trying to send out ads of their products on Facebook, but they do not know which ad would be better for which user would be more likely to click on it. So Facebook, let's say, gives that agency a list of all the people with their information, like this is the age of that person, this is the gender, this is the location. So which machine learning algorithm, which class of machine learning algorithm could you use that would allow you to target the ads in a better way? So I would just like to know guesses from you. Again, since I can't see the chat myself. I think the host would have to help me to give me an idea of what the majority guesses are looking like.
Yeah, so Venkatesh says it's supervised learning, while Suman is saying unsupervised.
Okay. So the audience seems to be split in this. So the actually there is no fixed answer for that. You could use any class of algorithm, but just with the information I provided, a unsupervised learning approach would be better. The reason is that you do not know beforehand which user would like which product. If you knew the input and the output, then a supervised learning could be a better option. But let's say you're just given information about the people, the age, gender, location, etc. What typical companies would do, they would create groups of these users. They would use some clustering algorithm, let's say all 18-year-olds in one group, all female 25-year-olds in one group. And then based on these different kinds of groups, send ads. So YouTube does exactly this. So what you will see on your YouTube recommendation sometimes is you get a random recommendation of, let's say, a puppy playing, right? How does it know that? Even if you never liked a video of that kind, why do you get the recommendation? And it turns out you actually like that. That's because it creates a cluster of people your age group. And if other people are liking that, then you also have a strong chance of liking it. So whenever you do not know the output beforehand, you normally create clusters to understand the data and then take a better action. So in this scenario, unsupervised learning would be a better approach. All right. So a second problem. Just one more problem, and I think we're good to go. So let's say you have a lot of data about the housing prices of a house. You know the number of rooms in a particular house, you know the location, and you know its price as well. So you have 1,000 examples of these houses, like a list of their area, number of rooms, location, and price. Based on this, if you want that, if you are given the size of a house, you have to successfully predict the price. Which algorithm in this case would be a better approach? Again, supervised, unsupervised, or reinforcement learning?
Supervised reinforcement, like majority of them are telling that.
All right. So I think there is lots of improvement in a very short span of time. So supervised would be a good approach over here. Reinforcement can also be in some form used, but supervised is built for this, right? When you have the input and output beforehand, you know that when the size of the house is this, the number of rooms is this was the price. So you use the data to learn it under supervision. So that is why supervised learning would be a good choice to go with. Finally, the last problem. Let's say you want to train a robot to play basketball or simply throw shots inside a hoop. Initially, you don't know the correct angle. You don't know what force at which you should be throwing the ball. Which algorithm could you train in order to successfully get the robot to use the correct angle and force to get basically the ball inside the hoop?
Reinforcement. The majority of them are saying reinforcement.
Right. I'm glad to hear that. And of course, yeah, reinforcement is the best choice to go with again because it's the same scenario, right? You have an agent, just the robot. It takes some actions, you give it some reward. When it takes a bad shot, you give it negative reward, and you use the learning algorithm which tries to map so that in future it can take the correct action to maximize the rewards. So these were the three types of classes of algorithms, and the only reason that I talked about them was to give you a glimpse of how you can go about the learning process. There isn't time left, I would say, to go into deep into these algorithms. Maybe we can leave that for some other day. But I think that was it from my side. If you have some questions from the audience, you can take that up, and we can wrap up the session.
You can feel free to raise hand and then you'll be unmuted.
In unsupervised learning, in the example which you gave, there is a sample data set of cats and dogs, it cannot identify which is a cat but which is a dog, but it can just differentiate. Yeah, these two are different. So like this was like there were less number of sets. Like if there were about 1,000 animals, if we can just say that okay, we have 1,000 different types of animals, but we cannot just identify which animal that is. So how is it useful?
All right. So that's a good question. So that would not be useful for, let's say, this cat or dog problem, right? So the only reason I took the cat dog example, so you could differentiate between supervised and unsupervised. But again, if let's say you have 1,000 examples of species and the model has successfully learned to differentiate. So if it's able to tell that a cat is different from a dog, it is not specifically able to tell that it's a cat, but it has successfully able to distinguish it. It has successfully been able to distinguish that. So what you need to understand that if it has been able to distinguish it, it has learned a lot of information about the particular image. So if not for this particular example, if we go back to the other example that I said about the ad agency, it can understand a lot of information about users. It can understand a lot of information about patterns. And the basic idea is it can create some sort of cluster. So internally, it would have created a cluster of data points where all cat images slide. And it would have created a cluster of points where all dog images slide. The point is unsupervised learning algorithms are great whenever you want to learn from data and find patterns in that. That is not particularly useful in this particular case, as you said, if you want to differentiate between dog versus cat. But there are a lot of use cases. Whenever you want to gain some sort of insight about, let's say, a user or any sort of input, that is where an unsupervised learning approach would be used.
Got it. Thank you.
Are there any more doubts or questions from anyone?
So I don't think there are any other doubts, right?
No, there aren't any.
So I think we can end the session as in just ending word. I would just say that it was fun taking this session, and I'm really excited for where these fresh graduates would end up, because this competition is intense. But I'm sure if you're on the right track and you build your skills well, you guys wouldn't have any problem navigating that, because you're a bunch of fresh, smart graduates. So I would say best of luck with the job hunting process, and I hope to see all of you making your own impact in some form of the other in this field. So best of luck with that for all of you attending the session.
Thank you so much, sir, for this very informative session. We got to learn many new things.
Yeah, also thank you so much everyone who has tuned into the session for paying attention throughout and making the session engaging. It was great to have you all here. Thank you and good night.